I'm going to start by introducing you to cormaclot chloride. If you're not familiar, cormaclot chloride, or CCC, is a gibberellin biosynthesis inhibitor. So it's a plant growth regulator, and it actually alters the plant's hormonal activity. CCC affects the GA pathway a little bit earlier than other GA inhibitors, such as tranexapac ethyl, which affects the pathway a little bit further down. And by inhibiting GA, it reduces the shoot length by decreasing cell elongation and the rate of cell division. It's formulated in Canada as manipulator, and it's currently sold by Beltchem Crop Protection Canada. Its primary use is to reduce lodging potential in cereals. So lodging, it's simply when the plant falls over, but it's an interaction of environmental forces, the plant itself, as well as the root cone and the soil conditions. So wind acts as a force that exerts leverage on the plant. Rainwater on foliage and ears increases the bending force of the stems and shoots. And there's two types of lodging that can occur in cereals. The first being stem lodging. Stem lodging is typically what we think of when we think of lodging. It's when the lower portion of the plant either bends or breaks, and that's due to the leverage on an individual stem being greater than the leverage or the strength of that stem, And then the second type of lodging is actually when the whole plant rotates from the base or from the root cone and falls over. And this is when rain typically will decrease the soil strength as well as the anchorage strength, and then the leverage on the entire plant is greater than that plant, or greater than the anchorage strength holding that plant up. Why is lodging such an issue for Western Canadian farmers? Well, it's not an issue every year because it's so dependent on the weather conditions and the growing season. But when it does occur, we can see a lot of losses. The first one being the obvious one, a yield loss. We can see 10 to 40% yield loss with a typical lodging occurrence in a field. We can see up to 80% in extreme cases. There's also a large amount of quality issues that can occur when lodging is present late in the season. And then just the operational costs will increase quite a bit. So the cost of actually getting that grain off the field at harvest, as well as any cost that we may incur if we have to start drying that grain. There are ways that the plant morphology can be influenced to reduce the risk of lodging. So we can decrease the stem or the plant leverage, for example, by reducing that stem length. We can increase the stem strength. A few factors that influence stem strength include the stem diameter, the internode lengths at the lower part of the stem, as well as increase the structural components of that stem. And then of course we can increase the anchorage strength to reduce that root lodging risk. So the structural rooting spread as well as the depth. I'll go over what that structural rooting area actually looks like a little bit later. But typically what we think of when we think of what a plant growth regulator or cormaclot chloride is how it's going to reduce lodging risk, we think of the reduced stem length, so decreasing that plant stem or plant leverage. But because we're altering a hormonal system as well as reducing stem elongation, there might be a reallocation of resources to some of these other plant morphological factors during the growing season. So the objective of this small part of a larger project is to determine the potential of cormaclot chloride to reduce lodging risk in spring wheat. The materials and methods, the data I'm going to show you is from a split plot design. We had 3 spring wheat cultivars as our main plot, Brandon, Cameron, and Prosper. We had 5 different nitrogen management strategies, 0, a low, a high rate of nitrogen applied at seeding. And then we had a split nitrogen application with seeding and flag leaf application. And then we had an ESN blend. And lastly, our PGR, or our chromoplac chloride, was applied as a split plot treatment. And that's really where we're going to focus today. We're going to focus on any results from the PGR itself, as well as if there was any interactions with those other two factors. We had site years at 2 locations in Manitoba in the 2018 and 2019 growing season. A little more about the PGR application itself, seeing as that's what we're focusing on. Chromoplac chloride was applied as manipulator using a single application rate of 1.8 liters per hectare. And it was applied at the growth stage 31 to 32, which is really when that stem is starting to elongate. And that worked out to about the 2nd week in June at all our sites. It was applied using a CO2 backpack sprayer. You can see in this picture on the bottom left, with a 4 nozzle hand boom. And these are what the plots looked like in terms of staging when that application was applied. The data that was collected off these plots, we had much more data than what I'm going to show you today. Today, we're just going to focus on a few of the lodging potential measurements that we took. Of course, we took lodging ratings. Lodging index we used was the area of the plot lodged times the degree of lodging. The degree of lodging was a 0 to 9 scale. Then we took canopy height. Lodging ratings was taken about 2 weeks after anthesis at the soft dose stage. Canopy height was taken around the same time. And it was an average of 5 readings per plot. And stock strength, the 2 pictures here in the bottom show the device we used to capture stock strength measurements. And it was developed at the University of Minnesota based on a Berry paper out of the UK. And we used it as more of a proxy to estimate lodging potential. A lot of data came out of this device. We really, for the purpose of today's presentation, I'm just showing you the static resistance force at 45 degrees from vertical. So we pushed a single row over to 45 degrees, and then we measured the resistance that that row of wheat was pressing back on that bar. And it was measured at half of the canopy height. Then we looked at structural root plate. So we dug up a 1/2 meter row length and washed the roots to look at the lignified roots that were providing the mechanical support of the plant. This measurement was really based off of Berry et al. 2000, which saw that there was a really good relationship with this structural rooting plate with the natural occurrence of lodging, of root lodging in particular. So we measured all the plants from the 0.5 meter of row length. The root plate depth was from soil surface to the lowest lignified root area, with the spread being the widest area. Data was analyzed using proc mixed and SAS, and linear contrasts were used to pull out any interactions we had. And any significant data that you see is based on an alpha level of 0.05 or 95% confidence. Looking at the growing seasons, I need to comment that in Manitoba in 2018 and 2019, we were drier than normal. You can see this red line in this graph is the long-term average, and all 4 of my site years were well below that during the growing season, particularly in this middle to late July period, which was really where you see the most lodging risk. So because of that, we did have low lodging pressure at all sites. And we had lower than normal yield potential at those 4 sites as well. But we did have lodging at one site in Manitou 2019. We had a heavy rainfall event around the end of July, which caused a bit of lodging. There was an interaction with nitrogen management by PGR, showing that when nitrogen was applied at a high rate, so the high rate at seeding, the ESM blend, as well as the split plot, all of those treatments saw a decrease in lodging when chromoplac chloride was applied. But at the low rates, the no nitrogen as well as the low rate, there wasn't actually enough lodging present to see a decrease in lodging occurrence with the PGR application. Canopy height, no surprise here, we did see a consistent reduction in canopy height with chlormaclot chloride application. There was a magnitude interaction with site year as well as cultivar, just indicating that at some sites, as well as in some varieties, there was either more or less reduction in canopy height. But overall, we had a reduction in height of 5.3 centimeters. Keeping in mind, because of the low precipitation at these sites, we actually had shorter canopies than what I would typically expect from these varieties. Stalk strength, we measured at 2 timings. We measured it at anthesis as well as maturity. At anthesis, we did see an increase in stalk strength with the application of the plant growth regulator. But when we took the readings again at maturity, that difference was gone. So there was no significant difference in stalk strength at maturity, indicating that possibly we could be reducing lodging potential at earlier in the growing season, but later, closer to maturity, we might not be seeing that benefit in stalk strength anymore. Structural root plate. We did see a significant interaction for both root plate spread and depth with site year. So looking at spread first, we saw an increase in root plate spread with the PGR application at 1 site out of the 4, and that was at Carmen in 2018. And then root plate depth, we saw an increase in root plate depth at 3 out of the 4 sites, with Carmen 19 showing no influence on root plate depth. This is indicating that possibly the resources that would have been allocated to stem elongation being reallocated to the below ground root plate area, hopefully increasing that anchorage strength with that PGR application at some sites. So in conclusion, natural occurrence of lodging was reduced by CCC at 1 site when high nitrogen rates were applied. Chlormaclot chloride showed potential to decrease lodging risk by decreasing the plant stem leverage. It did this through reducing the canopy height. Also increasing stalk strength. Stalk strength was increased at anthesis, but not maturity. And then also there is potential for increased anchorage strength. Root plate spread was increased at 1 out of 4 sites and increased root plate depth at 3 out of 4 sites. With that, I want to acknowledge my advisory committee, Dr. Yvonne Lawley, Dr. Nide Brule-Babel, and Dr. Don Flayton and Dr. Joachim Wiersma. They've been an amazing help during this project. And then also the scientists at University of Minnesota that we worked with to get that stalk strength meter going. And then all of the technical staff as well as landowners that helped with this trial. And then the funding for this project was provided by the Manitoba Crop Alliance. And with that, I can take any questions.